Welcome to T3, day 26 of calculus. We're going to continue speaking about volumes of revolution. So we're going to find the volume of a solid of revolution that is generated by rotating the region bounded by the given curves about the indicated axis. That's going to be some particularly common wording that you're going to see. So we're taking this function and rotating it around the x-axis, and we're going from x equals 0 to x equals 2 pi. So the first thing you need to do is graph this function. And yes, you need to know what that graph looks like without using a calculator. 3 cosine x plus 4 starts at 0, 7, and it goes down, and then it goes up. It does not go down and touch the x-axis, and this it'll hit at 2 pi, comma 7. It'll go back up. So we're rotating that about the x-axis, meaning you're going to take a slice. When you take a slice, let's say, I'll go red here. Here's a little slice we're going to take, and we're going to rotate it around the x-axis. So when we rotate it, you end up with this disk right here. You end up with this disk. What do you end up with for an outline? Well, you end up with the exact mirror image of this. It should hit that, so I'll make it hit. It goes like this, like that. So you end up with lots of these disks. All we're doing is we're adding together a lot of these disks. And how wide are they? They are a width of dx. dx is some infinitesimally small part. So you have all these different disks, and here's the edge of one of them right there. There's the edge of one of them. Kind of goes around like this, like that, like that. And the width is always dx. So what is this integral going to be? Well, remember, the thing we had before was v is equal to pi r squared times h, and h was always going to be dx in this case. We're going from 0 to 2 pi, so 0 to 2 pi of pi, and the radius in this case is 3 cosine x plus 4, and the width, and we square it because it's squared, and the width is dx. And what's nice about this integral right here is that you do not need to do this one out by hand. Oop, I jumped over. You can do this on your calculator, and when you do, you end up with 128.805. You should verify that with your calculator. So let's do this one. First, let's sketch the region. The region is y equals 0. Y equals 0 is just also known as the x-axis. That's y equals 0, also known as the x-axis. Y equals 5, like this. X equals 0, I'll use yellow here, this is x equals 0, and x equals 4. I'll go to this one right here, x equals 4. There's x equals 4. Ooh, I'll use highlighter. So we're taking this region right here, we're taking this region and we're rotating it about the x-axis. So we're taking it and rotating it right here around the x-axis. So when you rotate this, you end up with, oh, look at this, it's kind of cool. You end up with a cylinder. There's your cylinder. See the cylinder right here? So again, you could do the entire cylinder using calculus. We're going from 0 to x equals 4, and it's pi. What's the radius of this cylinder? The entire radius is always, sorry, that's not y equals 0. This is y equals 5, excuse me. 5 squared, and the width on this one is always dx right here. So this, when you think of this right here, the width of this cylinder right here, that one, is always dx. So that's the height if you look at it sideways. So what does this mean? You're doing 25 pi from 0 to 4 dx. This is the exact same one we did before, and when you integrate this, you get 25 pi x from 0 to 4. So that's going to be 25 pi times 4 minus 0, which is 100 pi. This is very similar to the one we did in the last video. You could also do this in terms of one cylinder, just whole one cylinder, and that's volume is equal to pi r squared times h, where the entire one, without calculus, you're not using integrals, entire height is 6, so its volume is equal to pi. Radius is 5 the entire time, 6. So, excuse me, it's not 6, it's 0 to 4, so it's 4. 6 was the last one, so that should be 4, like this. So you end up with 100 pi. You can do it both ways, and it's easier to do it that way, and you should be able to recognize that, but you can only do that because this doesn't change. It's y equals 5 the entire time. You would need calculus and change that radius right there if it was going to be a different function, like here. So if we take y equals x squared, which we know looks like this, there's y equals x squared, and we're going from 0, which is right there, all the way to 3, x equals 3, and we're rotating it about the line y equals -2. We have to be super careful here. Let's put some arrows on our axes here. Where's y equals -2? Well, that's right here. There's y equals -2. So what does this look like when we rotate it? Well, this shape right here gets duplicated down below right here. So there's the curve. There's the shape. Let me draw that a little smoother for you. So it looks like that in there. So this shape right here is exactly like this. And what's going on? This rotates. Let's do one more slice right here. This rotates right like this. So you connect this, you connect this. So what do you have? You have, oop, I didn't do that properly. This goes all the way to here, and this goes all the way to here. So you go to the back here. So you get a washer, the same thing we had before, but there's a hole cut in it. There's a hole cut in it. So what are we going to do here? We have a big radius and a little radius. The big radius goes from the axis we're rotating around all the way to the edge. So that's the big R. And the little r is the smaller radius. That's the little r. What we're doing in this case is we're going to find what it would be if you just rotated the whole thing and then took out this center part. So the integral we're looking at is pi times 0 to 3. That's this 0 to 3. And it's going to be big R squared minus little r squared dx. This you have to know. Big R squared minus little r squared dx. Our other ones we just did had no little r in it, so it was just 0. So it's big R squared minus little r squared. Our big R squared in this case is x squared plus 2. Sorry, just x squared, not x squared plus 2. It's just x squared. Oh, it is x squared plus 2, excuse me. Why is it x squared plus 2? Because what is the distance from here to here? That distance is x squared, but then you have to add in this plus 2 right here. You see that plus 2 right there? So this distance plus this distance is x squared plus 2. So big R is x squared plus 2. The little r is always 2. The little r is always 2 in this case. It stays consistent. It's 2 there, there, and there. So again, the big R goes from here all the way to here, and that's going to be x squared plus 2. So then you have this polynomial right here. You can simplify it and do it by hand, and you end up having to integrate this. Pi times, not integrating it, but evaluating pi times x to the 1/5 x to the 5th plus 4/3 x cubed from magical work from 0 all the way to 3. You have to plug in 3, you plug in 0. If you plug in 0, you get 0. So this is just going to be, let's plug in 3. 1/5 times 3 to the 5th plus 4/3. Oop, wrote that a little bit at an angle. Times 3 to the 3rd. Let's factor out a 3 to the 3rd. So it's going to be 3 to the 3rd pi times 1/5 times 3 squared plus 4/3 times 1 because we factored out the 3 to the 3rd. So we end up with 27 pi times 9 over 5 plus 4 over 3. Let's get a common denominator here. It's going to be 15, so multiply by 3. So we get 27 over 15 plus 20 over 15 right there. We multiply by 5 to get that, and we multiply by 3 over here to get that. So end up with 27 pi times 47 over 15. And you can multiply that out if you'd like, but that would be totally fine as well. Or just stopping right here is fine. I'm okay with that. But again, what did we do? The big thing you have to remember is if there's a hole in the center here, you see how there's an empty space there? There's a lot going on there. Let's try to erase some of this so you can see it. There's a lot going on. If there's a hole in the center, you're doing it with washers with a hole in it, so it's going to be big R squared minus little r squared. I usually don't do this, but I'm going to make sure I make this clear. It's big R squared minus little r squared. It is not this. You don't square the difference. It's big R squared minus little r squared.